going to look at here is when we have two numerical variables. So everything we've done so far in the class has been this idea of a single variable. So where we have this chart of temperature being recorded and chirps per second from crickets, so everything we've done so far, we would have only had one column of this data. And that's where we could create a histogram or a dot plot, calculate mean, standard deviation, do all those things with that single column of data. But now what we're doing is introducing a second numerical variable. And with this, we end up with paired data. Much like we have in algebra classes, when we graph x and y coordinates, it's that often we had some function relating the two. And for us, how they're going to relate is that they're collected together. The idea being that this data goes together and that this is saying when it was 89 degrees outside, they recorded 20 chirps per second. Then when it was 93 degrees, they recorded 20 chirps per second. So they relate together. So much like we have in algebra, we describe x as our independent variable. And then y is our dependent variable. And something we'll do, often it'll be given to us in order of x then y, but this independent and dependent we can kind of talk about in terms of what the variables represent since we have this context. And often what we'll be doing is describing one is the response variable, which is often y, since it's depending on the other variable, it's responding to how it's behaving. And then x, our independent variable that kind of works on its own, is going to be called the explanatory variable. So often it's the idea that the explanatory variable can explain some change in the response, given that they're related. We'll talk about why we need to be careful with our wording there. So in terms of this example where they're collecting the temperature outside and chirps per second from crickets, if we think about in terms of what works independently and dependently, temperature should be independent. It operates on its own based on other factors that don't have to do with crickets at all. And what we're going to see here is that with the crickets and the chirps per second, that could be responding to what happens with the temperature. They might be more talkative or less talkative as the temperature goes up and down. So with that idea that temperature works independently, chirps per second might be dependent on temperature, that helps us see that temperature would definitely be our x value and chirps per second would be our y value. Specifically in terms of response and explanatory, it's likely, more likely at least, that chirps per second responds to our explanatory variable, which is going to be temperature. So that's something to think about with these when we have these two columns of data. Think about which one should be working independently and what's likely to be dependent. Sometimes it can actually work both ways depending on the question, but often it should be clear of one changing because of the other. So from there, with these x and y variables, what we can do is create something called a scatter plot. And a scatter plot's going to graph this data, and it's going to be a scatter of different coordinates in that they won't connect with a line or anything like they do in algebra. Instead, they're going to be these independent kind of discrete points coming through. So for example, we'd have this coordinate 8920. So what we do is, and just as x and y operate, temperature is the x-axis, chirps per second is the y-axis, and you number it accordingly as you need to see it clearly. As you can see here, I did a little jump since for temperatures nothing happens between 0 and 65. So this little jump here just says there's nothing happening between there, and then we can start our consistent scale along that x-axis. So plotting this point where x is 89, y is 20, we go through and just plot our points as we would. So there's our point 8920. And then we go to 9320, which should be about right there. And we plot that point separately, and we don't connect them. And then 8117, and so on and so forth. I'm going to go ahead and pause the video while I fill in the rest of these. So filling in the rest of that scatter plot, it should look something like this. And the point of these scatter plots is, by plotting all this data together, what we want to start seeing are trends in the data. And specifically with this section being about linear regression, what we're looking for is roughly linear data. Meaning, if we plot this scatter plot, can I imagine a line going through the data that roughly fits it? You're never gonna, well, rather you'll rarely get data that makes a perfect line, but we want to see something that's roughly a line. And with that, we can get an idea of trend. So as we can see here, there's this trend that we start kind of low down here, which is the idea of having low temperatures with low chirps per second. And then as temperatures increasing, as we get to higher temperatures, what we see are higher chirps per second overall. Often there'll be some points that contradict the trend that you're looking at, but you're looking overall at how most of it is behaving. So some follow-up questions down here. Is an increased number of chirps per second caused by an increase in temperature? And we want to be very careful of this word, caused, because it's very definite. It's saying if we increase that temperature, then chirps per second has to increase. And we don't know that. Overall, we're seeing the trend that's true, but we need to be careful of this definite wording. So what we need to do is just be very careful. So no, we can't use this word cause. So we can't claim this causation or this cause and effect relationship, because what we need to be careful of are these things called lurking variables, which we talked about in our experiment design. We need to be careful of any other variables that are having an effect in here. And we'll talk more about lurking variables later on, but just to get at it with this example, be the idea that where we see this trend between temperature and chirps per second, maybe there's something else linking the two. Maybe something else happens that as temperatures increase, there's another variable that's taking effect that's actually causing the chirps per second to increase. So it's like there's this possible missing link here that's showing this relationship. So we need to be careful of those lurking variables. So we want to avoid any wording that's definite. So instead what we could do is say something along these lines, like what happens in general to the number of chirps per second as temperature increases? Well, in general, chirps per second increase as temperature increases. So talking about it, what happens in general, or the overall trend, or there seems to be an association, essentially we want to use kind of looser wording to describe these trends here to take care of the fact that there might be these lurking variables. So we might say there's this association or this relationship that appears there, but avoid cause and effect. And that's what's stated down here. While one variable looks like it might explain changes, be careful of using that word causes. We don't want to say one causes the other.